Hello all. We are learning a different Simulink library blocks where in the corporate browser we have learned about this Simulink library. Instead, we have learned about the various block like continuous, discrete or logical operator, math operation, string, source, signal attributes, port, subsystem, so many blocks we have learned, and we were learning some advanced modeling technique. So there is one more important library, a part of a Simulink in a similar in Matlab is Stateflow. This Stateflow you can see in a Stateflow we have the four parameters. Okay. In a Stateflow we have four parameters. One is chart, truth table, state transition table, and sequence table. So first we have to know about what is Stateflow and all this thing. Okay. So as we know, like previous sessions, we have learned various aspects of MATLAB and Simulink base development, like MATLAB and Simulink based development, where we have scripts using the Excel to the workspace to the Excel, and workspace is connected to the Simulink, and Simulink is simulated a model, even output to the workspace, or a output stored to the Excel sheet. In that way, like we have learned various aspects of MATLAB and Simulink based development. So in this further session, we'll take this journey further with a state flow and its application in the area of model based design and simulation. State flow is a visual tool which works either independently or in a combination with Simulink and offer the possibility of modeling a complex system using a state chart, flow graph, truth table, and so on. So, these complete sessions are like introduction to the concept of state flow and building a foundation for coming coming state flow. How we can go to the state flow basic things. Like after we have to follow some key features in that way we have to learn about this chapter. So, three of the questions like what is the state flow? This question will may come for everyone. Okay. So, what is the state flow? So, we will learn about this first. The what is the state flow? So, you can see state flow is a block set of assembly. Yeah, it's a block set of assembly. State flow extends the signal flow graph uh, flag paradigm. Paradigm means paradigm of Simulink with a state machine. State flow supports a flow chart and state chart. Chart can be implemented using C or MATLAB as an action language. Stateflow supports Melee, Muri charts. Events are available for asynchronous communication. Stateflow is full integrated with Simulink. Stateflow supports the embedded code generation as well for our purpose and all this thing. There we are working with the code and doing so many operations and all this thing. So Stateflow is a graphical design block set that in a conjunction with the Simulink offers the possibility of design and development of control logic with the help of state transition diagram, flowchart, state transition table, and truth table. Stateflow is available as part of a Simulink product and facilitates the design and develop a supervisory control, task scheduling, fault management, communication protocol, user interface, and hybrid system. Additionally, Stateflow describes a complex system behavior using finite state machine theory. In the same diagram, also we can do Stateflow allows modeling combinational and sequential decision logic together as a Simulink model block or as a MATLAB object. Simulating and debugging capabilities during a runtime is beneficial to analyze and get a desired system behavior performance. Stateflow is chosen over a Simulink to effectively impact state-based and conditional and timing-related logic. In a case of continuous changes in system or when the system requires complex math operation, then Simulink is preferred over Stateflow. Stateflow is proven beneficial in a various applications, especially in embedded systems like aviation, automotive, communication, industrial, and commercial, where graphical interfacing, hybrid systems, and so on, where we can use. Stateflow runs on Microsoft Windows, like where we want, where we install a Matlab, there it will, before installing a Matlab, it's mandatory to get activated the license for the Matlab, which is Stateflow also the one of the library. We also have to install a Matlab supports C++ compiler for generating a code for Stateflow model must be available if we are using the Windows version of a laptop. Like we have to please ensure that the Windows like how it will be coming and all this thing thing we have to do J64 setting, installation, code compiler generation tools we have to be installed. So the key feature of the Stateflow is Stateflow has a various application in different areas designing a control logic or like something like validation and code generation, code execution, like chat execution and debugging, developing a reusable logic with Stateflow. State editor is a very big window where we can, if we are entering in a state, then we can see what is the state editor and all this thing. Okay, so designing a control logic in a Stateflow offers a specified design tool to implement the complex logic designs that can have a defined operating modes with a state chart, flow graphs, and truth tables. Stateflow can implement it and simulate it as a part of Simulink model using a chart block. So there are state chart and flow chart. So what is the difference between a state chart and flow chart? We will learn in a further session. So still now we have covered what is a state flow and all this thing now. So there are some guidelines for a mixed use of Simulink and state flow, how we can use and all this thing that we learn. First, we will see about that here. Okay, Simulink and Stateflow are powerful combination. If you are able to see here, Simulink and Stateflow are a powerful combination. Simulink is used to respond to a continuous changes, where Stateflow is used to respond to a discrete changes. So in a real life scenario, we will have to do the combination of continuous and discrete changes to get desired some system like some object which we want to be delivered to the customer. So here we can combine in a Simulink and Stateflow to get some continuous and discrete changes together. So for example, in a basic way, if I am saying you the system need to be respond in a both continuous and discrete changes. So these are a few examples where the Simulink and Stateflow are a powerful combination. So in a vehicle, like suspension dynamics are a continuous changes, but discrete. What gear changes are a discrete. So you everyone know when we are changing a gear, we are not continuously changing a gear. Frequently we are changing a gear. But suspensions in a vehicle suspension canals which are getting power to the engine and all this thing, they are running continuously. Right? So these are the continuous model. In discrete models, we are using a straight flow. So we can say there are some instantaneous changes also we can do. Suppose we have uh, one if else condition, we can easily use a Simulink. But we have one if and multiple else if condition, it's better to use a state flow in that way. Okay, so the continuous in a vehicle system, the suspension dynamics are continuous and gear changes are discrete. So in like some aerospace, like propulsion system and lift off stages, these two will be there. And in some automation like machines and robotics and all these things, so rotational movement is a continuous and operational modes is a discrete changes. So where to use the continuous, where to use the Simulink and state flow, guidelines for a mixed use of Simulink and state flow. If the function primarily involves a complicated logic operations, use state flow diagram. Use state flow it is using a state flow diagram to implement model logic, where the control function to be performed at the current time depends on a combination of past and present logical conditions. If the function primarily involves a numerical operation, use a Simulink. Okay, if we want numerical operations, then we can use a Simulink, and we have like multiple conditions we have to follow. Then we have to use Stateflow, as we already discussed in that same way. So guidelines for the flowchart, truth table, and state machine. If a primarily nature of the function segment is to calculate mode of operation or a discrete value states, use state chart. Some examples are like a diagnostic model with pass, fail, abort, and complete states mode that calculate a different mode of operation for a control algorithm. And next is like if the primary nature of the function segment involves if then else statements, use a flowchart or truth table. So we will learn in our next session what is a flowchart and all these things. Flowchart is very important in a Simulink. So we have learned about that. Simulink and Stateflow are a powerful combination. System needs to respond to both continuous and discrete changes. That's why we are using a Simulink and Stateflow are a powerful combination to make a environment satisfied in that way. Okay, so that's all about the Stateflow introduction. Thank you.